With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello, so let's start solving the question, and question says this: the reduction potential value of SN2 positive to SN is minus 0.14 volt, and the reduction potential value for this PB2 positive to PB is minus 0.13 volt, right? So determine the ratio of that is determine the concentration ratio of SN2 positive to PB2 positive, right, at equilibrium, right? So for this the cell reaction is given here, right? So this is the cell reaction, and we have to take the value that is 2.303 RT divide by F is equal to 0.06, right? So we have to use this value, right? So let's start solving this question, right? So since we have given a cell representation that is like this, right, as SN2 positive, right? So this is cell and this is salt base here, and this is PB2 positive lead and is giving PB, right? So as you can see here, SN is going to SN2 positive, that means here oxidation is taking place, right? So that means here oxidation is taking place, right? So and here reduction is taking place, right? So here you can see that from this compartment reduction is taking place, right? So as we know that reduction is always occur on the cathode, that means this compartment becomes our cathodic compartment, and this oxidation occurs on anode, so this compartment becomes our anodic compartment, right? So the reaction becomes like this, right? So if I write down the reaction of anodic compartment, so the reaction will be like this, right? So this is SN, right? So this is SN which is oxidized, so it becomes at SN2 positive and it is giving 2 electron, right? So and at the cathodic compartment lead is reduced, that means Pb2 positive, right? So this is Pb2 positive, right? So this is Pb2 positive which is accepting 2 electron and it is getting as Pb solid, right? So it is accepting as Pb solid, right? So now the overall reaction becomes I can write here as the overall reaction, right? So this is overall reaction becomes here from 2 electron to 2 electron cancel out, and here stannous which is in solid state plus Pb2 positive which is in aqueous state, right? So it is giving, so SN2 positive plus which is in aqueous state here, and this is lead, right? So which is in solid state, right? So here this is the overall reaction, right? So this is the overall reaction. Now we have given the standard reduction potential value, right? So we have given the standard reduction potential value of SN2 positive to SN, right? So for this the value is given is minus 0.14 volt, and for the standard reduction potential value for Pb2 positive, right? So for Pb2 positive to Pb, right? So the value is given like this, right? So it is value is, this is Pb, that is lead, right? So the value is minus 0.13 volt, right? So this is our, you can say that this is our value, right? So Pb from Pb, right? So minus 0.03 volt, right? So here, so now here from you can find out the easily the E naught of the cell, right? So you can find out here standard reduction potential value, right? So from here you can find out the E naught of the cell, right? So E naught of the cell becomes E cathode minus E anode, right? So E cathode minus E anode, right? So always remember that in this formula you have to just put the value of reduction potential, not oxidation potential, right? So you know very well that which compartment is acting as a cathodic compartment and which compartment is acting as an anodic compartment, right? So as you can see here, the lead is compartment is acting as a cathodic compartment, and SN is compartment is acting as an anodic compartment, right? So just you have to put the value of reduction potential value here. So you will get here, so you will get, so minus 0.13 volt, right? So 0.13 volt, yes. And this becomes the anodic compartment is this, right? So just you have to put the value of minus 0.14, right? So the value becomes 0.01 volt, right? So this is the E naught of the cell, right? So this is standard E naught of the cell, right? So this is standard E naught of the cell, right? So but we have to find out the concentration ratio, right? So but we have to find out the concentration, right? So just we have to find out, this is the concentration ratio, right? This is SN2 positive divided by concentration of Pb2 positive, right? So we have to find this ratio, right? So we have to find this ratio, right? So for this, right, so for this we have to use the Nernst equation, right? So let me write here, this we have to find, and for this we have to use Nernst equation, and Nernst equation is like this. So Nernst equation is E of the cell is equals to E naught of the cell minus 2.303 RT divided by NF log Now it is a concentration of product divided by concentration of reactant. Now you can see here in the cell reaction, this is our product side, right? So this is our product side, right? This is our product and this is our reactant, right? So this is our reactant, right? So as you can see here, this is solid, and here this stannous is SN is also solid, right? So you can see this, the concentration of solid is taken to base 1, right? So you can neglect it, right? So here you have to just write the SN2 positive ion concentration, right? So I am just writing this concentration. I'm just writing this concentration is, it is SN2 positive ions, right? So it is SN2 positive ions divided by concentration of Pb2 positive ions, right? So now as you know, the reaction, we have to find out this ratio at equilibrium, right? So as we know that at equilibrium, right? So at equilibrium, right? So at equilibrium, the E of the cell, right? So E of the cell becomes 0. That means cell does not work, right? So at this E, at equilibrium, cell does not work, right? That means the equation becomes like that. So the value of this becomes 0. So it is 0, and the value of E naught of cell, so it becomes, you can see here, I can write as this is E naught of cell, and we have to use this value, that is this value, right? So this is 0.03. we have to use this value, that is 0.06, right? So this value, right? So in the question, right? So this is the 0.06, right? So we have to use this value, right? So for this we have to use 0.06, right? And what is the value of N? The value of N is 2, right? So because 2 electrons are consuming in the reaction, or you can say 2 electrons are oxidized and reduced, that means the value of N is becomes 2, right? So and here the log and the concentration of SN2 positive ions and the concentration of Pb2 positive ions, right? So this is the value, right? So now you can write here easily, you can easily write here, the value becomes 0 is equals to 0 point, right? So it becomes 0.01, right? So it is 0.01. so since we have calculated earlier, so it becomes minus 0.03, and here it becomes log concentration of SN2 positive divided by concentration of Pb2 positive, right? So this is the value, right? So now it becomes, the value becomes here 0.01 is equals to 0.03 log concentration of SN2 positive ions divided by concentration of Pb2 positive ions, right? So simply if I move here, so it becomes I can write here as it becomes 1 by 3, right? So it becomes 1 by 3 is equals to log concentration of SN2 positive ion divided by concentration of Pb2 positive ions, right? So now just take the anti-log on both sides, right? So just take the anti-log on both sides. So I can write here as take the anti-log. So I can say this anti-log of 1 by 3, right? So I can write here as the anti-log of 1 by 3, right? So this is 1 by 3, right? So anti-log of 1 by 3 is equals to log concentration of, or you can say it, so we have taken the anti-log, so it becomes SN2 positive divided by, this is concentration term, right? So and this is lead term, so Pb2 positive, right? So the value for this becomes 2.154, right? So this is the concentration term, right? So this is for SN2 positive ions, right? So this is SN2 positive ion and concentration of Pb2 positive ion, right? So you can see here the ratio of these two concentration comes out to be 2.14, right? So this 2.154, right? So let's check the option, right? Here if I check the option here, so we will find that 2.154, right? So we will get here 2.154, right? So this is 2.15, right? So this is up to 2 decimal, right? So you can see here the option A will become the right answer, right? And option B 5.35 becomes wrong answer, C also become wrong answer, and D also become wrong answer now, right? So the ratio of this concentration SN2 positive to Pb2 positive at equilibrium was found to be 2.15, right? So hope this answered your question. So thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.